Perfect. We'll go ahead and get started now. There'll probably be more joining later. I know we had a lot more registered for the sessions, but time is precious. So since we're such a small group, I'll go ahead and unmute everybody. Feel free if you want to mute yourself or anything like that. But because we're such a small group, more than happy to just, as you have questions, just go ahead and reach out directly. That way we'll have the slide open and we can go from there. First thing I just wanted to talk about is we're very proud of the fact that we won the AWWA Winner Innovation Award. It's the first time they've ever given such an award, and we're a relatively young company. So just by winning this about a month and a half ago, 2 months ago, really shows the efficacy of what we've been trying to accomplish. So we're very, very proud of this award. My name's Eric Trerotola. I'm the sales manager for North America. I handle all of Illinois. It's basically Illinois, West, South, and then West is kind of my territory. So Midwest, West Coast, Alaska. Didn't end up with Hawaii, but my boss ended up getting that. But that's the area that I handle. So water, why does it matter? I mean, it's just water. 70% of the planet is covered in water, but water is actually is an increasingly limited resource. And it's not just the water we're trying to save, but it's all the energy that we use for the heating, treating, and pumping of water. In fact, where I live in California, 20% of all of our energy that's used is tied to the heating, treating, and pumping of water. So again, it's not just the water as we think of it. It's all of those resources going towards it. And all that leads to time and money. So what is the size of the water loss? Well, in the United States, 2.1 trillion gallons are lost every single year. And that's a huge number. Something I couldn't even fathom. So I actually kind of geeked out in Excel and did some calculations. And that works out to be 33.4 days of continuous flow of Niagara Falls. That's 24 hours a day, 7 days a week going over. Worldwide, it's over 13 months of water flow. So the amount of water that we lose every year is astronomical. And again, this is treated water, not just any type of water. So what's the cost of the water loss? Well, some of our latest numbers, we have little more than $7.5 billion in 2019. And in the next 20 years, it's expected to be over $16.5 billion. All of that is a very small fraction of the actual money lost when you start calculating disruptions, property damage. You know, obviously you've got this vehicle that's in this sinkhole, all the tie-ups. I mean, this one event here easily in the hundreds of thousands of dollars. So it's not just the water that's lost, it's all of the disruptions and property damage. And again, that's just the water that's actually lost is a very small fraction of the overall cost. And most of the time, something like this started as a small to medium-sized leak. And leaks don't typically get better. They either stay the same and keep leaking, or they get worse and do something like that. So if we can stop the small to medium-sized leaks, we can help prevent some of these catastrophic events happening in the future. So kind of go through the agenda here. Talk about ASTERRA and Utilis, some case studies, some of our technology, what we call SAR, applications for water utilities. And like I said, we're a small enough group. Feel free to stop me at any point, whether through chat or through, I've unmuted all the lines here. So feel free to just ask a question as we move along. So a little bit about ASTERRA. Our official name is Utilis, and that's what we've had up until just recently, the last couple months. We're the same company. Our official name is still Utilis, but because we have a wider, broader product line, we moved it to ASTERRA because there's certain products that we have that are going to be actually getting out of just the utilities. Plus, just between you and me, it's some people just couldn't have pronounced Utilis. So we thought of ASTERRA, and we have now multiple products. Before we were just about leak detection. Now we have several products, and I'll talk about 2 of them today. And we basically got started. Our founder back, several years ago, was part of the team that helped find water on Mars. And they actually did find water on Mars. They actually found it 5,000 feet beneath the Martian surface. And he started thinking, you know, water is a limited resource. I wonder if we can use the same technology on Earth. And that was really the genesis of Utilis / ASTERRA and how we got started. By 2016, we had a product, and we did some of our first projects, and it was just kind of go from there. I work out of the San Diego office, San Diego, California, right here. We have an office in the UK, and then our production R&D is in Israel. We're actually have projects in 57 different countries, and we've done over 430 projects worldwide. Here's some other matrices: 36,000 verified leaks, some of the things we do on a yearly basis, which is all great. But really the main takeaway, and what does ASTERRA do? We make leak detection teams more effective. These benchmarks here, this is a 10-year benchmark, 1.3 leaks found per day is by an outside, it's 10 years of data where they're an outside contractor that it's all they do. They go out there, they've got some of the best equipment, the best trained people, and that's all they do. And oftentimes we look at utility companies or utilities, and they're nowhere near this 1.3. Our worldwide average is 3.5. So leaks found per day. So we basically just make leak detection teams more effective, and I'll get into how, but basically we isolate an area where leaks can be found. So using technology, using our satellite imagery. So let's get right into an actual case study. This one is in Hilton Head, South Carolina, and this was a leak that actually stayed hidden for actually a few years. Some of the contributing factors: the GIS data was inaccurate. It was about 100 feet off. I'm sure it was one of the only utilities that ever had their GIS data not perfectly aligned with where it was. You'll find that this leak was large enough that if they were near it, they would have heard it. This was a very large leak. But some of the main reasons why they weren't able to determine where this leak was coming from was it was in the middle of a tidal marsh all the way through. This is all a tidal marsh, so very inhospitable. The area was only partially exposed during low tide. The rest of the time was basically a flooded bay. There were no listening points when they designed the whole thing and running the line through this area. They never expected anybody to be using this area, so they didn't have any listening points. They had no low pressure events, and that was because it was proximity to a booster pump and an elevation tank. So they never had any drops of water pressure. The pipe itself was well within its useful life. It was only 25 years old. Again, no reason to suspect they would have a leak there. A little bit of a story about the leak. Visual inspection, once we actually guided them to this area that said, hey, we've got a leak here. They strapped on their boots and went trouncing through the mud, and kind of funny, they started to see animal footprints coming from all directions. So basically the animals knew where the best watering hole was. And we always think we're the smartest animals on the planet, but here's these animals, they knew exactly where it was at. It took us a few years to figure it out. Once they were there, it was a 12-inch main pipe, and there was a hole the size of a softball, so pretty massive. Looking at some of the older images that we have from Google Earth, you can see November 2014. The image there's nothing that's surfaced here. There's no blue lagoon that we saw earlier. But we look a couple of years later, October 2016, we actually see the blue lagoon starting to develop here. So sometime between November 2014, October 2016 is when actually it appeared. We move forward a bit, March 2018, you can definitely see the leak. And then just before we guided the crews out there, it was still there in January 2019. So we started looking at everything. Definitely 3 years for sure. We know that from the Google, but there was that 2-year period. So we can't be quite certain as to when it started, but we know it definitely in 2014 the leak was there. When they got out in the field, when they uncovered the leak, they determined that it was a 700 to 1,000 gallon per minute leak. So a massive leak, especially for going on for 3 years. And the leak was valued at about $500,000 per year. So at a minimum, it was $1.5 million, and easily could have been a $2 million or $2.5 million problem. I think Pete Nardi said it well, where he said a perfect storm of circumstances that allowed the leak to stay hidden and without ASTERRA could have kept going. For us, ASTERRA found leaks as small as leaking meters to one as large as a distribution main buried in the marsh, and fixing that one saved PSD and our customers about $500,000 per year. So let's get into how we're doing this. So what we're using is synthetic aperture radar, or what we call SAR technology. And basically how we do it is we're using a commercial satellite and a polar orbit. So it's going north to south, round and round the planet. Very unlike, it's basically the opposite of what you would, of most satellites we see on the Weather Channel, where that's a geosynchronous orbit. In other words, it's just kind of hovered over one area. Ours is going around the planet, and then basically the same area, it's going round and round, and then the Earth rotates, and that's how we get our coverage. So some of the advantages of the satellites, like I said, it's continuously orbiting the Earth every 90 minutes, goes round and round. Because we're in space, we can carry a lot of huge sensors. The satellites that we use are about the size of a school bus. So much heavier equipment, bigger sensors that we could carry because it's out into space, much more than like what an aircraft would be able to do. We can do frequent coverage. We can cover any place with the exact same angle. Like I said, we're at any point, we're going round and round the planet every 90 minutes. We can cover the exact same area every 2 weeks. So a lot of opportunity to do frequent coverage. And data is relatively affordable because one pass covers a very large area. How large? Well, here's an image of the San Francisco Bay Area. So you can see it's almost covers the whole thing. And a lot of times, even smaller utilities can share in the overall cost of getting an image done. So it's not just meant for large utilities, even small utilities can participate. So how we do this is we're using what's called side-looking radar. So in other words, we're looking at it at an oblique angle and emitting a signal, and then we record the return, the radar return. Very, very similar to what dolphins use with sonar, or even bats with echolocation. It's exactly the same thing, where you emit a signal and then get the signal back. Is how you're measuring things. This is actually the ALOS-2. This is the main satellite that we use. This is part of the Japanese Space Agency. We use two other satellites called SAOCOM-1 and SAOCOM-2. They're with the Argentinian and Italian space agencies. So all of them are commercial satellites. Everything's on demand. We're not using archived images. So we always have a very fresh image. Nothing's like years old or anything like that. They're just a matter of a few days or a weeks old for what we use. So some of the SAR capabilities, it can operate day or night, 24 hours a day, 7 days a week. It can see right through clouds. It can see through weather. Absolutely no problem. Sees right through that. It actually even sees through trees and foliage and anything like that. We use L-band, which is a very long wavelength, and it's really great because it's the ability to penetrate the Earth's surface. So it can actually penetrate on average, about 10 feet below Earth's surface, which is great because that's where most of the pipes are at. And although it can detect materials and objects, the reason why we use SAR technology is because it's extremely sensitive to water. It really lights up our scope when we're looking at things. So that's why we use SAR. But all of this technology has been around since the 1950s. And what really makes it special is our analytics. We're able to overcome a lot of the limitations of SAR using advanced algorithms. Some of the challenges that we have on Earth is, and especially with L-band technology, which we're in the 1 to 3 gigahertz range, there's a lot of interference and noise. We have conflicts with cell phones, Wi-Fi networks, microwaves, airport radars. It's just a very noisy environment. Our founder said it was actually easier to find water on Mars than it is on planet Earth, just because it was a pristine environment. They didn't have any of these problems of interference and everything. Plus, just the geometry. Again, we're using side-looking radar, so just with the physics of it, I won't get into the specifics of it, but we're actually looking, and actually it's more of an angle of about a 30-degree angle, 45-degree angle. So we're not right overhead. So if you've ever tried to look across a room and try to pick out the depth perception of where an object is in relation to another object, it's a bit harder than if you're right overhead. So we have the geometry to deal with. The curvature of the planet. comes into play. If you've ever tried to take a two-dimensional hand-drawn map and then try to wrap it around a globe, you'll start to see that things don't align. That's something we have to take into account. And then the planet is three-dimensional. We have a topographic distortions. We have hills, mountains, even buildings that we have to account for. And all of this, we have to make sure that it all aligns. So we geo-reference in our production, geo-reference, so that when we say where there's a leak and we send the boots out on the ground to go find it, it actually lines up to exactly where the leak's at. So these are some of the challenges that we overcome with our analytics. Here's another synthetic aperture radar image. This looks like, it appears to be like a road or something like that. I talked earlier about some of the interference. You can actually see it right here. You can see how it just totally obliterates any of the detail that's there. So this image hasn't been cleaned up yet, but we need to clean this up so we can actually see what's underneath. Each of these pixels, what it's actually showing is the conductivity of the different elements is what it's showing. We then convert this conductivity into a data table. And honestly, it looks like it's the matrix to me. I can't really understand it, but for our scientists, they're looking for the signature. There's a certain signature of treated water. That is water that has fluoride, chloramine, or chlorine in it. We look for those, and it's also basically all of those kind of drive to the same salinity as well. Again, it's the conductivity of it. And worldwide, an interesting thing that the entire planet, all humans, they pretty much like their water to taste about the same. So it's a very common trait. So we're looking for that signature of treated water. Now we're looking for that signature of treated water in saturated soil, which is why we're just not going to give you like a list of swimming pools in your area. We're looking for saturated soil with the treated water. That mixture is what kind of triggers and how we highlight things. So how are we using this? Well, don't want to get too geeky here, but we're using what's called dielectric properties or dielectric constants. And all elements have a certain dielectric constant. Air is 1, dry sand is 5, saturated sand is 30. Bottom line is everything has a very different dynamic property. However, water on average has about a dielectric constant of about 81, which it's the same. Now you're probably thinking, well, Eric, if that's the case, how did you guys find water and leaking water in a tidal marsh if all the water looks the same to you? Well, because we're using L-band technology and because it's a wide wavelength, we're able to extend that out so we can start breaking out the difference as we go through the wavelengths, breaking out the difference between seawater, sewage, and potable water. That's actually how we're able to do it. So I talked about, we have a couple different products. I'll talk about our very first product that we ever started, which was our leak detection product, and we call that Recover. So some of the current technologies that are going out there, you've got these 3 gentlemen here with listening sticks. It's kind of funny, you know, this black and white image. It's like, wow, that's so old school. They're going out there listening with sticks, but really the technology's changed slightly, but the premise is exactly the same. That is, they have to walk 100% of the system, just blindly walking, listening at certain points, listening for a leak, seeing if they can actually hear it. You know, although we do have a little bit more, you know, more advanced electronic listening devices and things like that, the premise, like I said, is exactly the same. You know, you just walk around listening and hope you find a leak. Another approach is to be a little more reactive to it. Just wait for something to bubble up, let for it to surface, let the customer call, and then you can go fix the leak. We can tackle this problem with some advanced areas with smart water networks, district metered areas, high capital expenditure, typically, a lot of training involved, and can really only be done in a very localized, smaller area. So what's wrong with the status quo? Well, you're basically searching around blindly. What ASTERRA does is we help you focus on 5 to 10% of the system. So what we do is these little yellow circles are called likely leak locations or points of interest. And that's the only part that you need to investigate. You don't need to go up and down every street. We actually give you we triage your system and show where we see leaks and direct your crews to those areas. So how do we do it? Well, first what we do is we get what we call the AOI, or the area of interest. That's basically a utility's boundaries of their area. We then order a satellite overpass and get the image. We then get the GIS data, and then we're off to the races. Next steps, after the image acquisition and analysis, we then deliver it either as a GIS data table into a data layer into your existing system, or you can use our system directly. That's UView and UCollect. This is great for the boots on the ground team. They can go out there, shows with their GPS, shows exactly where the suspected leaks are at, and they go out there, record their findings, and then everything rolls up into the dashboard. It's about a 5 or 10 minute delay, but it's pretty close to near time that managers back in the office can actually see what they're finding out in the field. Once they locate a leak, once they've verified it, they then mark it for excavation and then later repair. So what are some of the ASTERRA deliverables? Well, here's another list, another AOI, area of interest, with the different types of points of interest or likely leak locations. One of the things you can see is the leaks aren't evenly distributed. So, definitely in clusters, and I'm sure other utilities have seen that, there's always certain trouble spots. So just even looking at it one pass can really be used as an indirect condition assessment of where you might have some potential problems, in addition to just trying to go out and fix these leaks. Kind of just gives you a state of the state of an existing system. Zooming in to what some of these points of interest look like, it's basically what we would call a buffer zone. So it's about 300 feet in radius or 600 feet in diameter. And what we do is, with all of the GIS data, we highlight the area within that GIS data. So again, you're not walking up and down every street, you're only highlighting and walking down the areas within the point of interest. We feed back the GIS data that was given to us. So, any of the detail of the pipes is a PVC 8-inch. If there's any listening points, meters, hydrants, anything like valves, anything like that the crew can listen on, we show that back there in the UCollect app. So very handy to be out in the field. So let's get into another case study. This one is in New Braunfels, Texas. And this was a really interesting one. Some of the background on it, this one, the utility was just east of the San Antonio area. They have 573 miles of mains, and they did a 5-year effort where they were going through and seeing what they could find. So here's their 5-year results. For the total of the 5 years, they had 178 leaks total, averaged 35 leaks found per year. So not bad, but they kind of some of the stats here. They still, even after this effort, they still had 18% NRW. So they knew they needed to do something more. The previous system, the way they did it for the last 5 years, each year they were only looking at 20%. So that 5-year effort was basically one lap of their entire system. It took them 5 years to go through all 573 miles. And they had quite a bit of resources dedicated to this. They had a 3-man team going out there, boots on the ground technicians, plus you had supervisor support, planning, definitely a lot of labor invested in trying to find these leaks. In 2019, they commissioned Utilis/ASTERRA to come out and show them what we could do. And so we went through and we actually found 229 leaks that first year. We found 816 points of interest, those yellow things, and all of those were investigated. They inspected every single one. They calculated the leak flow rate and duration for every leak that was verified. Oftentimes people say, wow, Eric, I mean, 816 you called out, but you only found 229 verified. That's so 75% of the time they didn't find any leaks. Yeah, that's true. However, we're highly confident. We're about the 80% confidence level that when we say there's a leak, there is a leak there. However, you might not be able to acoustically sound it. And we're really comparing ourselves to what they were doing in the past. In 2018, they found 16 leaks. In 1 year, we found 229 leaks. That's the big difference. and they didn't need to walk up and down the streets blindly. So within this 1 year, we were able to do the entire system of the 570 plus mile system 4 times. So not just 20% of the time, we were able to do the entire system 4 times. And using the data, again, for the data that we collected, kind of that indirect capital pipe replacement program that I was telling you about. So one of the very first slides I showed you the benchmarks of 1.3, and that was a basically an outside professional team. Now that's all they did. You know, they had the best equipment, some of the best trained people in the industry, and they're at 1.3 leaks found per day. And I said all utilities, many utilities are nowhere near that threshold. Well, New Braunfels was having, you know, they were nowhere near that 1.3. In fact, they were at 0.06 leaks found per day. When you calculate that out, that works out to be 1 out of every 20 days they found a leak, which, gosh, that's frustrating. With us, they were finding 4.1 leaks per day by using our guidance. That's the big difference. The previous year, 2018, they found 16 leaks. With Utilis guidance, we found 229. And the thing is, we did it with with about a quarter of the overall labor. This is what really rolls up to huge labor savings. In fact, New Braunfels signed up with us. Well, they did the 2019 project. They did a 2020 project. They're in the middle of a 2021 project right now, and they just signed a 5-year agreement with us for the next 5 years, providing the same similar service, just to really drive their NRW. And so far to date, they just reported this last week. They've saved over $609,000 in water and everything. So kudos to them. They're really getting aggressive on their water savings. So if we kind of do some comparisons in the first year, they brought their NRW from 18% to 16.6 in 1 year. And we were able to find 14 times the amount of leaks, 229 versus the 16. And we found in the first year, we found 50 more leaks than they did in the previous 5 years. All of that done in 1 year. And all of it was done with a quarter of the labor. This was actually written up in the AWWA's Upflow magazine, January 2020. If you'd like to get a copy of it, let me know. I'd be more than happy to share it with you. Has a bit more detail than what I shared here, but very interesting, definitely very interesting. So I mentioned that we have a few different products now. So our second product is called Master Plan, and Master Plan is using the exact same technology. We just go about it a little differently. We don't provide points of interest. I mean, a lot of times we do both, give you the points of interest, but this gives you a different way to look at the data that's presented. So I'll get in a little bit into that. So some of the issues that are facing our utilities throughout the country is more and more environmental and sustainability requirements are really at the forefront. Huge movements here. Just trying to get done more with less, and our carbon footprint, and everybody's very, very cognizant of what's going on. At the same time, the United States is really to the point where our infrastructure is really aging out. Europe has actually gone through this a few times now, where they've had to replace their infrastructure. This is the first time we're a relatively young country, but we're at that stage now where our infrastructure is starting to fall apart. You know, we have places that are, you know, over 100 years old. I was in Green Bay, Wisconsin, not that long ago, and they had found wooden pipes in their system. So funny, they said they weren't actually on GIS, which is surprising. But yeah, so I mean, wooden pipes even. So it's time that we have to start replacing some of the pipes that we laid, you know, 80 to 100 years ago. Budgets have been limited, you know, with only a fraction of what you could spend to replace the entire system. Where do you start? Pipes are underground, they're not visible. So where do you actually go out there, and how do you figure this out? Well, a lot of different utilities are kind of start taking some of the things they know, the age, the material, the amount of service calls, the work orders that they have, and they start developing a picture, a predictive picture of where leaks might be occurring. This is what's known as likelihood of failure, which is great. And then you combine that with consequence of failure. In other words, you know, the areas near the city center, near a hospital, the consequence of failure is huge. So you kind of look at that, but I think of likelihood of failure as the future with our technology, or the near future is likelihood of failure. I look at our technology where we're actually seeing the deficiencies in the pipes. We're seeing the leaks. That's kind of the present. So I think if you have the actual failures, the present, combine that with likelihood of failure, which is the near future, combined with the consequence of failure, I think you have a really good picture as to where you're going to start to deploy your assets and which pipes you're going to replace. Gives you a lot of intelligence to act. So what master plan is, it's basically a GIS data layer of your entire system. Again, this is actually showing the deficiencies in the system. It's not predictive whatsoever. It's completely pipe agnostic. We don't even see the pipes, in fact. We're seeing the leaks that are outside of the pipe in the saturated soil, as I mentioned before. And it's non-invasive. We're not putting anything in the pipes at all. We're just seeing the saturated soil itself. And again, it's a real indication from a real sensor. It's not a prediction or a model output. All of it's delivered as a GIS data file. We basically give you a deficiency level score associated to the pipe ID. It can be imported into any software as a GIS layer. We actually are partnered with Esri Innovize Info Asset Planner, so it just kind of pops up there. So that makes it easy. But like I said, any software that can pull in a GIS layer, it could easily be imported in. So let's get into how this is all done here. So we basically rate all the deficiency levels between high, medium high, all the way down to low. And as you can see here in the Southeast, this is definitely in the high level. Here's high level. And so how do we go ahead and score that? Well, we distinguish between 3 of those different types of POIs. Those are those yellow circles that are showing you the points of interest. So if we see a leak in one area, we rate that a certain score. If it's a spatial POI, just a fancy way of saying multiple leaks in one area, we rate that a bit higher. Just rather than going onesie-twosie all over your system, we'll kind of consolidate things and say, okay, this is a higher leak. There's more leaks in this area, so we rate that a bit higher. And then we use a temporal POI. Again, another fancy way of saying over time. When we do master plan, it requires 2 different looks at the system itself. And that gives us a couple abilities. One, we can start prioritizing the single POIs. If we only have one pass, we don't know, when we see a leak, we don't know if it's a small leak for a long time or a big leak for a short period of time. We have no data on that. So if we do 2 passes over a given period of time, it gives us a lot more knowledge. And now we can start gaining more from that image itself. It's a bit more refined, and we can start differentiating one POI over another one, which one means a bit more. So again, over time, with a temporal POI cluster, we rate that a bit higher. We then weigh all of the different things per our algorithms and transfer this the score to the pipeline, which is what you see here. So some of the benefits in the return on investments, this just kind of breaks down kind of the life of 3 different types of leaks. One that is much larger, that's 3 times larger than the other 2. And it's all about what dictates how much water is going to be lost is based on awareness, how long it takes you to locate and repair the leak. So that one of the very first slides I showed where the sinkhole occurred, where the car was in the sinkhole, awareness was very quick. You knew about it. You were able to locate it because the news crew was probably there, and the repair happened quickly. So we oftentimes associate that with a major catastrophic loss of water, but in the reality is the awareness and location repair all happened probably within a day or so. So relatively not a whole lot of water is lost. A much smaller leak that goes on for a longer period of time has the opportunity for leaking much, much more. So here's one for just 14 days. And as you can see, it's actually leaked out quite a bit more. But really the real killer, the real driver of NRW or non-revenue water loss are the leaks that go undetected, the ones that go on for years and years. Those are huge. Those are the death by 1,000 cuts, as we call it, and they're the real killers for NRW and water loss. So what we help you do is we help utilities find background and undetected hidden leaks. 60 to 70% of the leaks we find are on small to medium-sized leaks. As I mentioned before, most leaks don't get any better. They either stay the same and keep leaking at that level, or they get worse and eventually lead to a catastrophic event like that sinkhole. Most leaks will be subsurface. If they weren't subsurface, the utility would have found that a long time ago. So most of the leaks we do find are subsurface, and the majority we find are on main, service leaks, meter boxes, and valves are where we're finding the leaks. So some of the other main benefits is we're able to do a wide system scan. Even when we do one scan, it can be used as a condition assessment to kind of see where some of the possible trouble spots are. And all of that data can be provided in an overlay, as like I said, a GIS data overlay for your pipe replacement programs and your master planning, identifying system trouble spots. Again, it's non-invasive. We're not putting anything in the pipes at all. We're just finding the natural treated water in the environment leaking out. No equipment's required, and really no upfront capital expenditures is required. In fact, we provide the full analysis, and boots on the ground team can go out there, start investigating. We provide that. We invoice it a few days later, and it's net 30. So in effect, you could be out looking for leaks and haven't paid $1 yet. The entire system can be scanned once or even a few times in a single year. And like I said, we really focus on the background leaks, the undetected leaks. Again, a death by 1,000 cuts. And that's how if you can capture that, not only will you reduce your overall NRW, your non-revenue water loss, but you'll help prevent some of the big catastrophic events moving forward. And it's by far the most cost-effective tool for regulatory compliance. Boy, that was a mouthful. That was a lot. I don't know if you guys have any questions at all. It's been a bit quiet, but I'm happy to answer any questions you may have. I believe everybody's unmuted, but let me just hit that button there. I think the only people that are muted under their own choice. But if you are muted, feel free to type something in chat. Be happy to answer any questions. A lot of the questions that we get, I've already talked about pools. How do we differentiate between a swimming pool and since that's treated water? We do see them, but we screen it out because it's not in saturated soil. So we don't do that. We don't give a list of where all your swimming pools are.
Hey,
oftentimes, yes.
This is Steve Cole, and with the Great Lakes Protection Fund. Great presentation, so thanks for that. Was curious. I think you mentioned this earlier on about your algorithms being able to be able to detect different types of water. So I was wondering if you've given any thought to applications of this for wastewater. So looking for leaks in the wastewater system rather than in the drinking water system, and also whether so moving on from there, whether you've ever looked at detecting failing septic systems using the same approach.
Yep. Yes, we have. Matter of fact, they're both in our beta testing right now. Couple challenges with wastewater. Typically, they don't have the PSI, nor do they have the number of listening points available. So identifying where there might be a leak, pinpointing where there's a leak, it can be a bit of a challenge. So the way we deliver it is more at the master plan level. In other words, it's showing you the deficiencies of the pipe. But definitely, it's something that we're currently in beta testing. If you guys are interested in that, we can see if you would like to join the program, but it would require 2 separate scans, two overpasses, and we're definitely working on that. And we can actually look at the signature based on any uniqueness of your overall system. We can kind of tweak our algorithms of what it's looking for. On the treated water side, just to give you an example, Portland, there was we're doing a project there, and they had a chlorine shortage. So to make the amount of chlorine they had available, stretch out, they reduce the amount by 30%. So we tweaked our system a little bit to where, you know, we can do that. So if you happen to know some of the specifics of your wastewater or anything like that, it helps us identify it.
All right, great, thanks. I may follow up with you by email.
Yeah, please do. And I've got a question from Joel. Can you describe your fee structure for various services? So having a local microphone issues. Oh, no problem, Joel. Yeah, so basically our fee structure is, I kind of showed that large image of the San Francisco Bay Area. So a number of utilities can jump in on it if they're smaller. If you're over the 225 linear mile, then it really doesn't matter. You've kind of met that threshold already, and it's really at a per linear mile charge. So it's $80 a linear mile. So you can kind of do that's for one scan and analysis and everything. And that's for the POIs. If you're looking for something like master plan, then we need a minimum of we need to do 2 scans, but rather than $80 a linear mile, it's $65, but then you times 2. So if you had 225, it would be what would it be? 450 times 65. And then for the master plan add-on, it's 15,000. Everybody's case is a bit different. I'd be more than happy to do some proposals or cost analysis for you to kind of break it out. That's what I do. So be happy to do that and give you a general idea. That's where it's at. We've done systems as small as, you know, less than 15 miles. You know, it's just they were tied in, you know, they were within that image, and they had kind of like some other local sister agencies that were a bit larger that allowed them to get to the linear mile. So that's how the price breaks down, Joel.
Otis.
I don't know if there's any other questions.
Yeah, quick question, actually. I'm Amy. I work for Pinnacle Reliability here in Houston. We actually work with some wastewater facilities, but we work with the facilities directly, not necessarily the pipelining. Kind of seems like y'all work more in that widespread piping. I was just curious if y'all have ever looked into working with like the facilities more directly. I know that satellites, that probably isn't the most efficient way to do it, but I know there's some other technology out there. Was just curious if y'all were involved in that at all.
Yeah, I mean, we've worked with both utilities, AECs, you know, consulting firms, directly. It's kind of a wide gamut of who we're working with. I would say most of the time it's the utilities, the facilities that we have worked with. Anybody that's awesome. their overall, you know, charter is looking after their piping system and the health of it. Yeah.
Thank you.
You're very welcome. And again, that's all my contact information there. Anybody has any other questions, I'd be more than happy to answer them, or, you know, like I said, you know, feel free to reach out. If you'd like a specific proposal, I'd be more than happy to write one up for you. Just would need to know roughly the amount of linear miles that you may have, and I can get to work. Just let me know where it's at. And that's about it. If there aren't any other questions, I wish you guys have a great rest of your day. And please send me any emails or anything like that you might have any further questions. Perfect. Thanks, everybody. Take care.